Hello and welcome to Lesson 5 in this series, Representing Characters.
To start, press any key. Where's the any key? I see ESC, Catarl, and Pigup. There doesn't seem to be any key.
So as you can see here, there's quite a lot to cover because we've got characters, we've got images and sound. So I thought it would be better to do this as a series of 3 quick videos rather than one long video. So today we're just going to go through characters and what do we need to know about this for your exam. When you press a key on a computer keyboard, a code is generated that the computer can convert into a symbol for display on screen or for printing. It is clear that it is important that systems agree on the codes being used if the data is to make sense. There are agreed international standards that are used to represent the character sets for a computer system. A character set is every character the computer can understand. This is very important because not so long ago there were lots of different standards in different countries. And if they're all representing text characters in a different way, it's very difficult for computers internationally to send and receive information, which is very fundamental when you think about things like the internet, the web, and email. In 1960, the American Standards Association agreed a set of codes to represent the main characters used in English. This is called ASCII, American Standard Code for Information Interchange. This system was agreed to deal with basic textual messages and included codes for things like all the main letters of the alphabet as characters, both upper and lower case, so that's 52 characters, all the numeric symbols 0 to 9, that's 10 characters, 32 for punctuation other symbols, so that came to actually 33 characters with the space, and another 32 codes for non-printable control codes. So you put all that together, and this is what you get. This is your ASCII table. So we've got the values in decimal, and we've got the values in hex, and then the symbol that they represent. Now you can see that kind of first column here is kind of all the control characters. We don't have to worry about that too much. But then over here we've got things that are more important. We've got punctuation marks, we've got numbers, we've got all the uppercase and all the lowercase characters. Okay, so obviously when it says here that A is 65, obviously for the computer this would be a binary sequence, it'd be 1 and zeros. It's just easier to say 65 just now, it makes a bit more sense. Now the good news is you don't have to memorize this table, you just need to know a little bit about it in order to be able to describe it. So you need to know that it has control characters, punctuation, numbers, uppercase and lowercase characters. It would be useful to know things like, so if A is value 65 and B is 66, then clearly A and B have one difference. If you add 1 to the value of A, then you get the value of B. If you add 1 to that, then you get the value of C, which is 67. As there are 128 values, from 0 to 127, that need to be represented in binary, ASCII uses 7 bits to represent each character. So the first value would be null, and that's just 7 zeros. A, as we've seen already, is value 65. In binary, that's 1 and then 0, 0, 0, 0, 0, 1. And the final value, the delete, is just 7 ones. 1, 1, 1, 1, 1, 1, 1, 1, probably too many, 7 ones. And that comes to 127 and the final value that can be represented using 7 bits. Now, if you're not sure why these binary sequences represent these numbers, I will go through this in more detail in another lesson when we look at binary number systems and converting between binary and numbers that we're more familiar with. But just briefly, binary works by, if we start over at the right-hand column, this would be value 1. And then every time we jump 1 to the left, it goes up by a factor of 2. So the next column is 2s, then 4s, then 8s, 16s, 32s, and the final column has a value of 64. So if you look at this binary sequence, well, we've got 1, 64, we've got 1, 1, total of 65. If you add all of these together, for example, for the next value, you've got 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. And if you add all that together, you get 127. So 7 bits can represent 128 values from 0 to 127, and that's what ASCII originally used. However, in the exam, binary representation of ASCII will use 8 bits to make it a full byte of information. So in the exam, A would be represented by 0, 1, 0, 0, 0, 0, 0, 1. Okay, you've got that extra 0 just added on there to make it a full 8 bits. Okay, so don't be confused by this. It's just how they're going to represent it in the exam. Moving on to extended ASCII. ASCII only represents the standard characters on an English keyboard. To include common non-English characters and mathematical symbols, the extended ASCII set used the full 8 bits in a byte to represent another 128 characters. This expands the original character set to 256, so from 0 to 255, rather than the original ASCII limit of 128. So if you look over here, we have the original ASCII characters, but now we have this extended sequence now with the values from 128 to 255. And you can see that now we can represent lots of symbols used in foreign languages. You can see that we've got some more mathematical operators, some graphics and symbols and things like that as well. So you can see now this would be a lot more useful for people in non-English speaking countries. However, there's still problems. How do you represent Chinese characters? How do you represent Arabic characters? It's still very limited. Which brings us on to the next character set we need to know about. Unicode. Unicode was developed originally to use 16 bits rather than a single byte, providing the ability to store 2 to the power 16 unique characters, or 65,536. So that gives it a lot more space to store lots of different characters and symbols from around the world. Later developments of Unicode use even more bits to represent potentially billions of different characters, including graphical symbols and emojis. But cleverly, to ensure compatibility of all these different systems, the original ASCII and extended ASCII character codes are the same within Unicode. They are now just a subset of Unicode. So if you look at Unicode, the first 128 characters are the same as ASCII. The next 128 characters are the same as those extra symbols from extended ASCII. And then after that, you have all the new characters and symbols. So that provides quite a large degree of compatibility between different systems. So here you go. You can have a look now. These are some of the extra symbols and characters that you'll find in Unicode that you won't find in ASCII or extended ASCII. So we've got all your emojis, we've got all kinds of different symbols, we've even got playing card characters and things like that. Because modern Unicode can give you up to billions of different characters and symbols, and it's constantly being added to all the time. Again, you don't need to know this in any great detail, you just need to be able to describe it and just to kind of state how Unicode improves and expands on ASCII. Let's go through how we calculate storage for text file sizes again, just to give you a little bit more practice. So remember, text file size is the bits per character multiplied by the number of characters that you wish to store. So a question might be something like, how much storage is required for 1,000 characters of a 16-bit Unicode file? In an exam, they're not going to ask you to do any difficult mathematics because you don't have a calculator. If you do get a question, it's going to be stated in such a way that all the units are going to be easy to multiply and divide in your head. So if you look at this, this isn't too difficult. 16 bits per character, and there are 1,000 characters, so that gives you 16,000 bits. We then need to simplify that. We take that 16,000 and divide it by 8 to give us 2,000 bytes. And we take that 2,000 bytes, divide it by 1,000 to convert it to kilobytes, and gives us a final answer of 2 kilobytes. So again, that's not too difficult. That is something that you could do in your head. As a teacher, I'm not sure how many questions like this they would possibly give you in the exam. Again, you don't have a calculator, but if they do give you a question like this, it will be in units with numbers that are easy to work out in your head with just a little bit of maybe double checking and a little bit of patience. Okay, that's all from me today. I hope that was really useful for you. I will be back soon with another video on how we represent images. Good luck with your studies.